Okay, so let's start off by I'm going to kind of flip through our slides here and point out highlights of things that I think are relatively important that you should definitely know for the exam. I don't remember if I told you last time or not, but the exam I designed it to take about an hour, 50 minutes or so. So hopefully, if you know your stuff, time should not be the stressor for it. The exam will be about 20% programming, something like that. Then the other 80% will be kind of short answer essay type stuff. So understand that I recognize the fact that several of you, as you're catching on to the programming stuff, still are going to find it difficult to write programs live, right? Just sit down and just write it without having too many mistakes. So a couple of things to keep in mind is on the programming section, since you're handwriting it, I'm not going to be nitpicky about like semicolons and stuff like that. I'm looking for general competence. Do you pretty much know what you're doing, or are you completely clueless? Okay, realistically, it usually falls into one of those categories. Okay, there's rarely that little position in the middle where, like, yeah, I kind of don't know what's going on. It's always either, hey, I haven't really been doing my homework myself, but I've been riding somebody's coattails, or I've been working really hard at this and I pretty much know what's going on, but if I had to write a whole lot of code in a short period of time, I probably wouldn't be able to do that right now. That's kind of where probably most of you should be, is that writing code from scratch is going to be a challenge. So I'm not looking for perfection there. Okay, so certainly kind of know where Java fits into the world. We talked about some of our historical languages and the evolution of those guys, so understand those steps. We'll flip through that here in a second. So always come back to this, how human beings solve problems. I don't know if I'll ask this question directly, but at least indirectly you need to understand this concept, that this is how human beings solve problems, and programming languages provide facilities for these things. Okay? Certainly what a programming language is. That's the mapping thing, what we just talked about. Questions that I typically do like to ask will be things like, what's a primitive type? Is this maybe I show you a method header or something like that. I ask you, is this a class method or instance method, and how do you know? Maybe I ask you, how do you call class methods? How do you call instance methods? Things like that. So all those little cadence things that we've repeated over and over and over again, those will make the test. Okay, so go and memorize those things. Those should be free points. All right, no excuse if you miss those. Let's see. I won't ask about any of the PHP, Ruby, Python stuff. I'll just talk about kind of the lineage that we're interested in right here. So kind of our evolution of C to C++ to Java, those things we talked about. So when we talk about C, we think about that through the lens of variables. So this is our precursor to our object-oriented languages. And then what did C++ bring to the table? Well, it added the idea of a class. So that gave us that abstraction for object-oriented programming. So we want to understand that. And then kind of where we took the jump for Java. We just talked about it, did I not write a slide for it? Yeah, evolution of Java, this guy. So from C++, we went to Java. We kept variables, we kept arrays, we kept classes. We removed the struct type. Took away poor decision making. So that was the whole idea of in C++, you can hand somebody the house rather than give them the address of the house. And then also removed a lot of fluff. So extra things that you have to type in C++ that aren't necessarily required, but are just kind of a permanent cadence you have to do every single time you write a program. You have to write the same crap over and over again. Java has kind of abstracted out. They also took away a specific syntax for pointers. All right, so certainly understand those steps, that evolutionary stuff from C, C++, and Java. Understand what functions are. Functions, methods, procedures. So this idea of reusable chunks of code. Plan on writing one. Usually the two questions I'll ask on an exam, one of them be write a method that does something. The other one might be write a class that represents, I might kind of almost like a word problem. You know, like right now we're writing things for like a player, those types of things. So give me a class that represents a fraction where you have a numerator and denominator and have a method that displays it or something like that. So kind of showing that you understand the idea of how objects are put together and how they work and that kind of stuff. Let's see. Certainly procedural versus object-oriented. That was that telephone example we talked about. So procedural telephone has all the wires exposed. Object-oriented looks like a phone, only the public interfaces are there. Probably would not waste a question on Java versus C# and how they're actually built from a virtual machine perspective. So interesting trivia knowledge, definitely important to know, but I wouldn't spend time reviewing that for the test. I don't think I'll waste a question on that. What are primitive types built into the language only capable of holding a value? Understand these different primitive types. I won't ask you to like regurgitate numbers here like this, but it would be fair game to ask like a question like why are there so many different ways of holding whole integers, positive and negative whole integers in Java, something like that, dealing with cost of memory. Historically, Java is based on C++, which is based on C, which is from 1968. Memory used to be really, really, really expensive, so we have a bunch of primitive types for kind of handling different sizes of memory, so understanding that historical thing. Let's see. I do like conversion questions. So it wouldn't be out of the realm of possible for me to ask you to like convert from binary into decimal or decimal into binary or even from like, you know, kilobits to megabytes or something like that. So these conversion slides, I would probably only ask one conversion type question. Usually it would probably be something with bases. So convert from, you know, base 10 to base 2. Let's see. Certainly understand the concepts of pointers, what they're for, how they exist in Java. We don't have a specialized syntax for working with pointers, but we still have memory. You know, an array is a pointer to a place in memory, that kind of stuff. So we've spent some time talking about that. But understand kind of the principle that a pointer is a primitive type variable capable of holding a memory address. That's what it does. We talked about this idea of side effect as it relates to pointers. So this idea that when you pass something that is by reference to a function, so like an array, and you make a change to some bucket of that array, that's a permanent change because you're actually changing it up in real memory as opposed to having something passed by value where you're getting a copy of it. So pass by reference versus pass by value. I mean, certainly all of these guys. Another question could be, what's a boolean expression? Any expression that boils down to a single value of true or false. So all those things where I ask you the same crap over and over and over again probably will make an appearance in some form, at least some of that, on the exam. I mean, certainly be comfortable with the boolean operators, not the bitwise stuff though. So the ands and the single ampersand, the single or, and even the exclusive or, don't worry about those. So normal ands and ors, and then the mathy ones, less than, greater than, that stuff. Basically be able to build boolean expressions. We talked about the bitwise stuff in here and how it works. I won't test you on that. Just kind of be aware of it for in case sometime in the future you run into something and you think somebody has a syntax error in their code, but you're not sure why it still runs. They're either doing something stupid or doing something mathy. Okay? I understand the difference between the assignment operator and the equivalence operator. That's more, I guess, common sense stuff. These would be things that when you're writing your code by hand, try to spend special attention to these, whether it's a single equal sign or the double equal sign, so I'm convinced that you know the difference. Certainly conditionals versus loops, these are kind of just our building block type stuff. Know about our 3 different loops. I probably would not waste a question asking you what kinds of problems does each one lend itself to. Yeah, I don't think I would, but understand that we have 3 different kinds of loops. I doubt I would ask a programming question that says you must use a while loop or you must use a for loop to solve this. I certainly would want you to solve problems in terms of what we've talked about in class, but if you're more comfortable with one loop versus another when you're writing your code, I'm looking for your best shot at showing me competence rather than trying to fit some mold. Certainly understand the modulus operator and how this guy kind of plays in. It's possible that maybe one of the programming questions would involve that. I probably would not ask you just a random question like, what's the modulus operator or something like that. It would probably be maybe part of the problem solving in one of the programming questions. Plus, plus, minus, minus, this could be potentially fair game if I'm kind of desperate for another question or something like that. And I ask you, maybe I give you like 3 or 4 lines of code and ask you what's the value of A at the end of this or something like this. So understand the difference of the plus plus and the minus minus, whether it comes first or comes after, and how that impacts the value of it. So fair game, but I would say low-ish risk. Not a difficult concept anyways, but just understand that. I won't ask anything specifically about compound operators. You never have to use these if you don't want to, so I mean it's their conveniences, but I won't ask anything specific. Definitely be comfortable with methods. A fair question that would not count as a programming question might be to ask you to write the method header that fits like a sentence. Write a method named ABC that takes an integer as a parameter and returns a string. Write the method header for that. All right, so something like that, just so you can prove to me that you know where the return type goes, where the method name goes, and how the parameters work. Not write any of the logic, just the header. That might be a fair game question. Okay. Certainly, static keyword versus non-static keyword, the difference between class and instance members, fields and methods, those things, all the kind of the anatomy stuff of a object, of a class in Java. I probably would not ask you a question specifically about compilers. This was more talking about kind of our discussion about the evolution of our languages. Earlier compilers were single pass compilers, so you actually had to write your code in a certain order to make sure certain things got hit first. Important to know, important to understand how we got to where we are today. Probably not something I'll test you on. Certainly concatenation, very important. Certainly fair game to be tested on that. Obviously, strings, big deal. I mean, so I could, like I said, you might only have 2 questions where you have to write code, but I might give you code to read and say that, tell me what this does, or what's the output of that, or what's wrong with this, stuff like that. So be familiar with some of these string methods, important ones, length method, char method, our little trick with index of. Substring's helpful, but I would say substring is probably a relatively low risk on an exam. I probably won't ask you to My guess is that in the programming questions, you won't have to use substring for anything. But certainly index of and char at, the tricks involving those are what I deem to be pretty important. So certainly these three methods, length, char at, and index of. Again, static versus non-static. All right, so this is where we started getting into creating our own objects. So we thought about, so this might be kind of a fair gamey type question for one of those programming questions. If I say, hey, create a class that is meant to represent a dice object, where a dice has a number of sides and has a name, and then maybe there's an ability that a dice has to roll itself, something like that. So write the roll method. So something relatively short, but still proving that you understand the concept of object-oriented programming from creating a class perspective. Certainly understand the concept of a constructor. I would anticipate on that question involving creating an object for something that you will have to write the constructor for it to initialize that object. So understand the concepts of those, know how to write them, that kind of stuff. This keyword, super important. So very possibly I'll have a question specifically about this, or I might show you some code and ask you what's the difference between these two lines, something like that. But know how this keyword works and how an object refers to itself from within itself. Certainly public versus private is kind of fair game, protected. We're not in that world yet, so that doesn't really make a whole lot of sense for us. But I might ask a question like, why should we make all of our variables private by default, or something like that? Why is that good practice? And have you kind of explain from there. I probably would not, on the programming questions, take off points if you, like when you're writing your class, if you did make it private or something like that. I'm looking more for logic competence than did you remember every little stupid keyword you're supposed to have in there, that type of stuff. Like I said a few minutes ago, it's usually pretty obvious whether somebody generally knows what they're doing or whether they generally don't know what they're doing. So when you're doing the programming questions, try to show me as much competence as you can in terms of what you know how to do and stuff like that, because you're not going to get partial credit for like writing the word int or something like that, especially when integers aren't involved or something like that. I like when I give quizzes in some of the classes, it happens in here where I ask something completely different and they answer one of those memorization ones, like how do you call class methods or something like that. And it's not the question I asked. It's just, so don't do that on the exam. Well, I'll laugh, but which might help you on some of the other questions, but not on that one. Okay. Certainly understand the necessity of getters and setters and accessors and mutators. Well, these are synonyms for each other, right? But that kind of goes hand in hand with the private stuff. When you make a variable private and you need to access it from outside of that, you need to give access to it somehow. So a getter to get the value, a setter to set the value because you don't have direct access to that variable. So understand that concept that if you were to expose for read-write access or something like that, a private variable, you need a method or a couple of methods to pull that off. I probably wouldn't ask you to come up with these names, like, the accessor and mutator things. That's the old school way of calling them. Now we call them getters and setters, but I won't test you on the names, but understand what happens when you make a variable private and how that limits access to it. Certainly arrays, I would say fairly important. I would say there's a high likelihood that one of the programming questions will involve arrays, being able to work with these guys. Also, there could be a non-programming question where I maybe ask you to write the one line to create a integer array capable of holding 10 things, something like that. So in array AR equals new in array 10. So just proving that you understand how to work with arrays and how to define them. And or reading code that uses arrays. So this is kind of what I'm talking about when we create an array. So this would be creating an array capable of holding 5 integers, something like that. And this is kind of where our talk with all the pointers and stuff like that started coming up, where the variables point to the beginning of the array. They don't actually hold the array itself. New keyword, definitely important. So be able to, it would certainly be fair game for me to give you a couple of lines of code and then ask you what's the output of this. So kind of maybe a common thing I might do is something like this. I might say random r is equal to new random, and then system.out.println r, something like that, and ask you to tell me what the output of this program would be. What would I get? A memory address-y thing, right? Because this new keyword's involved here, and I'm printing out the value of r, not one of its methods. So this is proof of pointer type stuff. So I could give you 2 lines of code like this and ask you what the output is, and you should recognize that the output of this is going to be a memory address. So jumbled up letters, say memory address, whatever, but something that indicates that you understand the purpose of this new keyword is it's our real estate agent inside of our programming languages to go and ask the operating system for a chunk of memory big enough to hold one of these dudes. Okay. So this is the whole pass by value, pass by address. A fair question might be, what's the difference between pass by value and pass by address? Something like that, or I might give you an example of an array being passed into a function, and then I change the array or something and ask, does this have a permanent effect or something like that? So remember, arrays are passed by address, so when we pass them, we're passing a pointer to where that array actually lives in memory. So any changes that we make would be permanent changes. Whereas when I pass something by value, this goes back to our example from class where I said, if somebody is asking you where your house is, you give them the address of your house. If they're asking to borrow a quarter, you're probably going to hand them a quarter, not send them on a wild goose chase. So we pass quarters by value. We pass houses by address. Tell them where to go to find the house. That's our real life example for those 2 things. Okay, so understand those concepts. I probably wouldn't drill you on these from the perspective of trying to trick you. So I wouldn't look for that. I wouldn't look for questions that write really crazy looking code with the purpose that I'm trying to trick you into answering wrong. Okay, I'm looking for competence, not during test anxiety that you're able to see the joke or something like that. Okay, so usually if I think the code that I'm writing or the question I'm writing is a little convoluted, I'll give you kind of a hint or something like that. But during the exam, if you're not clear on what I'm asking, just come up and ask, and I'll clarify and I'll announce to the whole class if it's something that it seems like the question is misworded or something like that. So don't guess if it's not clear what I'm asking. Certainly the difference between arrays and strings. So if we're saying an array of characters versus a string, what's the difference? Well, arrays are read-write. So we can access elements of an array. We can also change individual elements of an array, where strings are read-only. If we want to change a string, we have to rebuild the whole string from scratch, right? That's with our concatenation stuff. So kind of understand that generalistic concept where strings are kind of abstractions of arrays. They have a lot of power tools built into them for doing things with strings, but what you give up is the ability to directly change them. Okay? Yeah, so this is basically what we just said. Read-only versus rewrite. I love this word, polymorphism. I don't know if I'll ask it, but if it's not asked in the midterm, it'll definitely be on the final. So that idea of when we have more than one method with the exact same name, but a different number and or type of parameters, that's polymorphism. We talked about the toString method. Okay, so that's when we have a class that by definition, so if we created our dice class, so we say dice d equals new dice, and then we say system.out.println d, we get a memory address by default, right? Because we inherited a toString method from probably our grandparent or something like that, the object class that lives in Java, and that provides us with a toString method, and that toString method gives us the basic guess at what displaying this guy should look like, which is going to be the memory addressy looking thing. If we choose to override that toString method and provide our own local one that maybe shows 2d8 or something like that, you know, a more appropriate output for our dice object, then when we print out the dice, system.out.println d, it's going to show something more appropriate than just a memory address. Okay? So understand that would kind of go hand in hand to what we wrote up here, this guy, where if I showed you a definition for a dice class, for example, and inside there I wrote a toString method, and maybe the toString method, you know, returns the number of sides and the quantity with the d in between it or something like that, and I ask you, what does this print out? You should understand that the toString method changes the effect of this guy. Okay, so if we happen to know that the random class had overridden, is that even a word, or is that well, close enough. If it had overridden the toString method, we wouldn't be able to just blanketly say that'll print out a memory address. Because likely if it's overriding the toString method, it's going to do it so it shows you a more appropriate value or something like that. Okay, so understand the role of that toString method and how it works. Let's see. Is this our bubble sort? Yeah. So understand the concept of bubble sort. I wouldn't ask you to write one from scratch or something like that on the exam, but I don't know. I might ask you to do the first couple of moves or something like that on the bubble sort. You know, maybe I'll show you something that's partially sorted and say this is the current state of like the follower and that stuff. You know, tell me what happens next or something like that. So certainly understand how bubble sort works, but more from an academic perspective, not being able to write it from scratch. Recursion, understand recursion. If I ask you what is recursion or something like that, I probably wouldn't ask you to write something recursively for one of the programming questions, but certainly understand that recursion is when a function calls itself from within itself. We used factorial as our example for recursion. I probably won't ask anything about the stack. That's more of a next semester thing for details about this. We talked about it in terms of how recursion is actually implemented, that copies of a method kind of get thrown onto the top of the stack so that we can come back and pop it off later when we actually have the values that we need to evaluate that particular call to that method. But I don't think I'll ask you anything about that on the exam. Certainly merge sort, similar to what we said about bubble sort. Understand the concept of merge sort. You know, there could certainly be questions involving it, but it wouldn't be programming based questions. I wouldn't ask you to write all the recursive calls or something like that to split the thing up or anything, but at least academically understand what a merge sort is, what's good about it, what's bad about it, that kind of stuff. So this is all of our merge sort crap. I could potentially ask a question on Git versus GitHub. What's the difference between those? You know, Git being the tool that allows us to create local repositories, GitHub being a website that allows us to host public repositories, that type of thing. Not a super high risk of this, but if I'm desperate for a question, I could certainly see asking something like that. Okay, so let's say that that is where we'll end for material in the midterm. I won't. I mean, we're starting to write some new stuff here with our rooms and stuff like that, but I won't. None of the new concepts we're introducing for that are going to be part of the midterm. So midterm is everything we've talked about today up through GitHub. Okay, so questions about the midterm, format, or things you want me to review. Anything's fair game. So if there was something I just mentioned that I say I want you to know, and in your mind you're like, okay, well, I'll go and figure that out, but you want to see an example, I'm happy to give you an example. Go ahead.
Can you explain static versus not static?
No. Static versus non-static. Okay. So let's go. How's our Ninja Warrior training going, by the way? We're going to start running the bluff, right?
Sure, yeah.
Let's see here. All right, so first of all, we're going to say static members. Well, here, let's give a little definition for members first. So class members include fields, which are our variables, right? Constructors, same name as class. And by the way, asking what are the class members, that could be a fair question. So what I'm answering here would be fair. And then methods. All right, so those are our class members. So members can be either static or non-static. So we're going to say static members only exist once and belong to the class itself. We call upon static members, I'm going to say static or class members, using the name of the class in which the member was defined. Okay, now the reality is constructors would never be static. So, you know, we might throw a caveat in here. But certainly fields and methods can't be. We would only use a constructor when we're creating an instance of a class, therefore it breaks the definition of why we would ever have something be static. Okay? But static members use the name of the class in which are called using the name of the class in which the member was defined, and they're defined, let's see, we call upon a static class, and they're defined with the static keyword prior to the member. All right, so that's our static stuff. Non-static members exist once per instance of a class. And this was supposed to be belong. And belong to individual instances of the class. We call upon non-static members using an instance of the class in which the member was defined. Okay. These guys are defined without the static keyword prior to the member. All right, so kind of two sides to this. One is, how do we call them once they're already defined? So when we look at their definition, how do we know whether it's a class or an instance method, or a class or an instance member? That's looking for the static keyword to be there or not be there. Static means it is a class member. Not having static there means it's an instance member. Flip side of the coin is how do we call it? Well, if it's a class member, we call it using the name of the class in which the member was defined. If it's an instance member that is not having static in front of it where it was defined, we call it using an instance of the class in which it was defined. That make sense? So that kind of covers both sides of it. So, but do understand on the test, an important thing is going to be understanding the difference between telling whether a field or a method is a class method or an instance method, both by looking at the definition of it and understanding when you're looking at where the method or the field is defined, you're looking for whether the word static is there or not. When you're looking at the thing actually being used, the static keyword doesn't exist over on that side. Okay, when we see something being used, you know whether it was a class method or an instance method or a class field or an instance field, depending on how it's being called. Is it being called with the class name or is it being called with an instance of the class? Make sense? So two different sides of the coin. Go ahead.
Is an instance method like a couple of class sessions ago where you said this dot is, I think this was the class.
Well, this keyword is how an object refers to itself from within itself. So if we kind of come down here and we're talking about our rooms, for example, then we say, yeah, here. So we have a room has the ability to add an exit given the name and destination or something like that. So inside of our room class, we would have a non-static, i.e. an instance method. To add an exit. All right, so because every room, and we have a cave or whatever that's made up of a bunch of rooms, each individual room has to have the ability to add exits to itself. Therefore, we need this to be an instance method so that each room has the ability to add exits to its individual self as opposed to the global room in general having a big collection of exits. All right, so that's when things would be non-static in that particular case. This keyword, so if we're kind of throwing this in a little bit of context here, this only exists within a non-static context. So for instance, if we are in the body of a static method, we do not have, let's put not in caps, we do not have a variable named this. Okay? This is how an instance of an object refers to itself from within itself. If I'm in a non-static context, if I'm in a static context, that is the body of a static method, that method is owned by the class itself, not a particular instance of the class. Therefore, this keyword does not exist. Okay, because we're not talking about an individual copy of a room. Here's one room, here's another room. We're talking about this global concept of a room, if it's a static method. And therefore, when we say this, we don't know which room we're actually talking about. That's why it doesn't exist in that case. So this is a non-static variable, only accessible from a non-static context, where context means where we're trying to access it. Inside of a method, that kind of thing. All right, what else? So we're all going to ace the exam, 100%. Now remember, we talked about this day one of class, but I do have a policy, so if you come to the exam and you bomb this one, and you do better on the final, I'll replace your midterm grade with whatever you get on the final. So, I don't think you should get screwed over for one bad day, but at the very least, the midterm should give you an idea where you are relative to where you should be. Okay? It doesn't go the other way around, though. If you get a 95 on the midterm and then you get a 20 on the final, I don't go the other. Okay? You're supposed to be better by the by the final than you are at the midterm. All right, any other questions? Going once, going twice. All right, so let's go back and look at our code a little more. So if I remember correctly, we at the end here we had our kind of a little collection of rooms and stuff kind of coming together, right? Let's get Eclipse open here. All right, so here's our driver. Inside of our world, we have rooms, we have exits, we have players. What's a room? A room has an array of exits. A room has a integer that tells us the current number of exits. A room has a name, and then a room right now is allowed to house a single player. By definition, there is no player in that room. Okay, in our default circumstance, there's nothing in that room. So a room comes into existence. What happens? Well, we bring it into existence, giving it its name. So this is our constructor. Notice the constructor has the exact same name as the class. And in order to construct a room, we require a name. So we go ahead and set the name to whatever was passed in. Then we initialize the player that might be in that room eventually to null. No player in there right now. We go ahead and initialize our exits array to be 4 exits, north, south, east, west, I think is what we said we can have, right? And then initially there are no exits. Okay. Here's our method down here for adding an exit. This is what we were kind of just talking about. So this would be an instance method. That is, here's the method definition. Notice we do not have the keyword static out front here. Okay, so since we don't have a static out front here, we know this guy belongs to individual instances of the room class, not the room class in and of itself. So we would not say room.addExit. We would say r.addExit, r2.addExit, that kind of stuff. All right, so when we add an exit, we're going to pass in the name of the exit as well as the room that we're going to, the destination. And we're going to go ahead and set the exits at the current number of exits. So initially this would be 0. So the very first exit we add to a room, we'll add the exit at bucket 0 equal to a new exit with this name and this destination room. And then we'll increment our current number of exits to be 1 bigger. So that the next time we try to add an exit, we'll put that at bucket 1, then at bucket 2, then at bucket 3, and then we're out of exits, so don't try to add more. Because we've limited our number of exits to 4. In our little world here. All right, so notice here we're creating a instance of our exit here. So just by looking at this part of the code right here, what do you suspect the constructor for the exit takes as a parameter, or takes as parameters? So we're looking at it being called here, not defined. We'll flip over to the exit class here in a second and see it being defined. But what do you expect to see in the constructor for exit, given the code I have highlighted there? What do we need? What is the constructor going to request from us in order to build an exit? I want you to read from what's on the screen here. Okay, I'm passing it 2 things, right? 2 things. I'm passing it a name. I'm passing it a destination. What's the destination type? What kind of animal is this? Cat, dog, person, room. That guy's a room, right? All right, so destination is going to be a room. That's the second parameter that's going to go into the exit constructor. First parameter is a name. What kind of animal is name? It's a string. So when I go over to the exit class, I should see a constructor in there named exit, right? Because it has to match the class name. And that guy should require a string and a room as a parameter. Otherwise, I must not be calling it correctly here, right? So let's go over to exit. Here's our constructor. Takes in a string, takes in a room, and it just sets those 2 things. Make sense? So again, that's showing us this is the definition of the exit constructor. This is us using the exit constructor. Constructors are always used after the new keyword. New keyword will always be present when we're calling upon a constructor. Okay. And then right now a player has a name, and then we introduce this idea of the scanner. What does the scanner let us do? Not on the midterm, but important for the second half of the class.
Receive input from the user.
Yeah, in our case here, receive input from the user, but we attach the scanner to some input stream. The one we're using is system.in right here. So that is our keyboard. But later on, we'll see we can attach a scanner to a file, stuff like that, to read things in from a file one line at a time. So scanner lets us read things in from some source. In this case, we're reading it in from the user. All right, so every player is going to have a name, as well as, we'll think about this like a walkie-talkie, communication channel to the player's keyboard. Okay, constructor for player is just going to take in the name. We'll set this player's name to whatever we've said their name is, and then we'll go ahead and initialize the scanner to the system.in, which is the keyboard. We wrote ourselves a method here. Is this a class method or instance method? Looking at the method definition here. Instance method, how do you know? No static, perfect. All right, so we wrote an instance method here called display to user that takes one parameter, a string that we've called message, returns nothing, and what does it do? It just spits out to the user's screen whatever the message was. Okay, and then we have another function here called show prompt. Again, no static, so this is an instance method. Takes no parameters, returns nothing. It's going to print out a little prompt thing here, and then read something in from the user. Okay. So here is, we put a little comment, we're going to be processing the commands the user puts in, so that's what we'll start working on today. So let's go back to driver here and see what we're doing right now. Right now we're creating two rooms. A cave entrance, that's a room whose name is the cave entrance. And then we're having a second room called room 2. Very great naming conventions. We're going to go ahead and add an exit to our cave entrance named north, and the destination will be room 2. Okay, so if we're in the cave entrance right here, we just put that door in, and that leads to room 2 out in the hallway. Okay, that's the other room. Similarly, we added an exit in room 2 called south, which goes back to this room. So if we're standing out there, we put that door in on the other side that allows us to come back into this room. Okay? Then we went ahead and we created our instance of player. Okay, and we had a cameo for the follower. And then we added that player to the cave entrance. Remember, every room has the capability of holding a player, but by default, no rooms have any players. But we went ahead and added this player to the very first room. So when I hit play here, we should see down the bottom, you have entered the cave entrance. Possible exits are to the north. Okay, showing me that it went through that whole exits array, in which case in cave entrance, we have one exit to the north that leads to room 2. Okay, from looking at our text here, we don't necessarily know this leads to room 2. We just know that there's one door in this room, and it's to the north, and explore at my own risk type thing. Okay, so what we'd like to do here is we'd like to be able to type in north, press enter, and right now, that's not spelled right, is it? I was testing you, and it's always either 1 R or 5 R's. I can't tell. Rarely are there 2 R's in a row. All right, so everybody failed that quiz. All right, so in any case, we're just proving that we can read in what the user typed right now. But now we want to actually be able to process that. So if they type in north, let's take the exit to the north. If they type in south, take the exit to the south. Right now, we only have this loose, these loose rules about what exit names can be. So really, anything that they type in right now, we're going to assume is an exit, is the name of an exit. So if we want to call one of the exits tree, which would be, climb a tree or something like that, we can name it whatever we want. That's what will pop up here. So we can't just assume north, south, east, west necessarily right now, but we'll come back and see we're going to have a limitation here in a little while. But right now, let's just make it go to whatever the exit is. All right, so we want to go into our player. And here we've read in from the user their response. So this is where we just read in north, for example. All right, so we have the user response. Now we need to go ahead and process that response. Okay, so right now we're going to assume that anything they type in is going to be an exit. Okay, that's the only thing we can do in our little world right now is we can see obvious exits, we can type one of them in, and then it'll take that exit. Okay, so what does it mean to take the exit? So we just typed in north. So we read in north into user response. So when we type in north, assuming that that's a real exit, that means that whatever room we are currently standing in, we need to walk through the door to the north in this case. That is, walk through the exit whose name is north. And when we walk through it, we want to ultimately end up in the destination room associated with that exit. Okay? What are exits? Exits are names and destinations. So we want to go through our array of exits that lives in room. This guy right here, the exits. Looking for an exit whose name is north. Once we find that guy, we want to get that destination room. We want to remove ourselves from the current room and add ourselves to the destination room. Make sense? Okay. So right off the bat, we have a problem. I'm here in player. I have my user response. We want to move to a new room. When we move to a room, we're moving to a room in terms of the room we are currently standing in. From a player's perspective, does this player know what room they are currently in? The room knows about a player. Player does not know about the room they're in. They're getting some stuff printed to their screen about it. But right out here, when we said, where do we go? Cave entrance.add player, passing it the player. What ended up happening here? Cave entrance was a room. We called add player, took the player in. We went ahead and set this room's player equal to the player. Then we displayed some stuff to the user. So we said, you have entered whatever. Here's the possible exits. We looped through everything inside exits. And then we told the player to show the prompt. At no point in time do we actually let the player know or give the player access to the room that they're in. Okay, so that guy doesn't know how to talk to. My team was defeated 203 to 80. Packer bye week. I refuse to bench Packer players. I think I told you, Jordy Nelson's still in my starting lineup. It's belief. All right. So, at no point in time, if we put ourselves in the shoes of a player, okay, and that's kind of the picture I want to paint here, is we want to think about these guys. This kind of connects us back to last semester when we thought about in Game Salad, we had actors that are in the scene, that kind of stuff. So right now we have this little 2-room cave that we've built here. So this is cave entrance, and that's room 2 through that door right there. And at this point, only I exist. I'm the player. Okay, so I'll be the player in this case. All right, so we're out here. This is our, everything happens, everything begins and ends with main here. So the director of our show here has said, okay, well, we're going to create a couple of rooms. We're then going to link those rooms together through exits. Then we're going to go ahead and bring the follower in. A little bit of a creepy name for me, but that's what I go by now. So we bring the follower in, and then we go ahead and toss the follower into the cave entrance. Okay? At this point in time, when we just kind of went through that room add player thing, at this particular time, this room knows about me. But if I look inside of my tool set here, from my perspective, all I know about is my name and how I can read stuff in from the keyboard. Those are the only two pieces of information that I know. I'm very limited on what I can pull off. Okay? So, if I want to take exits, right now the room is talking to me, right? Maybe it's a little bit backwards. Instead of me looking at the room and seeing what's in here, I don't even know about the room. The room is talking to me, so it's almost like I'm blind. And I just hear things whispering in my ears, okay? So the room is talking to me. It's saying, you have entered the cave entrance. Obvious exits are to the north, blah, 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 okay? So I now am aware of that, but accessing that entrance, or that exit rather, is something I can't do right now because I don't have access to the room that I'm in. So we need to go ahead and provide a player with a way to access their current room. Okay? So we're going to say private room current room. By default, this dot current room is equal to null. So when a player is first born, they're not in a room. Okay? But when we add that player to a room right here, we want that room to go ahead and let that player know about themselves. Okay? Now the issue here is inside of player, room is a private field. What does it mean for a field to be private? Go ahead.
It can't be accessed outside of the class without a password.
Okay, well, without some sort of access thing, right? So it can't be accessed outside of this guy. So that means inside of room here, where I'm adding the player, I can go ahead and set the, so maybe right here at the top. Let's go ahead and say, let the player know about the room they are entering. So I might want to say the player dot current room, right? Which is the variable that the player owns, current room, but it's a private variable. I don't have access to it from outside of the player class. So that means I need to have a setter, correct? We have getters and setters. Getters allow us to access to get a private piece of information. Setters allow us to set private members. So at the very least right now, we might need a getter later on, but right now we need a setter. We need to have the ability for the room to let the player know that they've entered it. Okay? So we'll go ahead and generate our setter here. Now understand all a setter is I would write a method here. Public void set current room. And this guy would take a room R as a parameter, and then we would say this dot current room is equal to R. Ooh, hello. Something like that. So that's a setter just as much as if we had used the built-in source thing, generate setters and getters, or getters and setters. We'll ultimately do the same thing. So I would come in here to current room. I would have had an option for set current room, but I already wrote that. So that's why it doesn't show up here. And then it would have generated it for me and written this code for me. All right. So now we've given ourselves access to a player's private current room. So now our room can let the player know about themselves. So I would say the player dot set current room. So I want to set this particular room, the room that we're entering, to the player's current room. How does an object refers to itself within itself? I need to pass the player the room that is this room. So I'm going to say this. The this keyword is how an object refers to itself from within itself. Right now, I am sitting inside of a particular instance of the room class. How do I know I'm in an instance of the room class? Because the method that I'm sitting inside of is an instance method. It does not have static defined out front. Therefore, we're operating from a non-static context. In a non-static context, we have access to the this keyword. And the this keyword is how this particular room, in this case, this room is our cave entrance. But inside the room, we don't have access to a variable called cave entrance. The only way we know to talk about ourself is through the this keyword. Make sense? So we're going to say, as the player is being added to this room, we're going to go ahead and the room's going to say, player, I want you to set the current room to me. Set your current room to this room. Make sense? All right, so now a player knows about that. Next part here is set this room's player to the player and display details to the player. All right, that's what's happening secondly. All right, so now it's two moves that happen inside of add the player. We let the player know about the room they just entered. We let the room know about the player that's now in it. Okay? So given that, we go back here to player. Now, when we read something in, now we have access to the room we're currently standing in. It's called this dot current room. That's the room we're currently standing in. So if I'm in here and I just typed in north, I want to take this room, and the way I reference this room is by saying this dot current room. That is the room that I'm currently standing in. I want to tell that room that I want to walk through the door. Okay, I want to take an exit. So let's go into room. And we're going to go ahead and we're going to add a function here called takeExit. Public void. Actually, let's have it do this. We'll call it takeExit. It's going to take in the name of the exit that we want to take, as well as the player that's taking the exit. Okay? Actually, let's think about that. Right now, it doesn't need to know about the player because this guy already knows about the player through his variable called the player. This is going to probably change in the future as we start allowing more than one player to live in a room. But as of right now, if I'm standing here and I say, room, I want to take the exit to the north, the room knows about me. I don't have to say, send me through that exit. Okay? In a few minutes, well, or next time, or after 2 classes from now, I guess, if all of us were inside this room like we are right now, now we have a collection of players. Just yelling, I want to take the exit to the north isn't enough because the room doesn't know who yelled that. So we have to say, it was me. I want to take the exit to the north. All right, that's when we would have to pass in to our room a second piece of information. That is the player that's going to take that exit. Make sense? But we'll let this grow slowly for right now where a room knows about the player that's in there. So we want to take an exit named exit name. I'm going to have this guy return a boolean because we want it to return false if the exit they tried to type in wasn't a real exit. All right, so what we're going to do is we are going to loop through this particular room's exits, looking for an exit whose name matches exit name. All right, if we find it, we want to actually remove the player from this room, add them to the next room. Okay, Let's start off with our loop. So we know that we have cur number of exits, right? That's how many exits we have in there. So we're going to write a loop that's going to go for int I is equal to 0, I is less than this dot cur number of exits, I plus plus. So this will allow us to check every one of the exits that actually exists. Because right now our exits array is capable of holding 4 exits, but we don't necessarily have 4 exits. We have cur number of exits. Okay? So we'll ask the question, if this dot the exits at bucket I dot get name. That'll get us the name of that exit. So if you come into exit here, we have a private string called name, and we have a getter for that string. So an exit knows how to advertise its name. All right, so we're going to ask exit I, what is your name? If your name is equal to the exit name we're looking for. Okay, so dot equals. I'll go ahead and show you a second version of dot equals here. There's a dot equals ignore case as well. So that allows us to, whether we type in north in all lowercase or north in all uppercase or capital N, whatever, this will match it regardless. Okay? Similarly, we could have said dot get name dot to uppercase dot equals exit name dot to uppercase. So we could force both sides to be uppercase and then compare them in uppercase. All right. Or in our case here, we could just assume that the user is going to type in exactly what the name of the exit is, not do too much extra error checking. So right now we'll just ignore case, just so you have one extra little equals tool in your toolbox. So we'll compare the name of the current exit to the exit name that the player has indicated they want to take. If we found a match there, and notice that we can't use the double equal sign here. We have to use an instance method from the string class. Double equal sign is the equivalence operator for primitive types. Strings are object type variables. Double equal sign is not going to work for us there. All right, so equal ignore case. If we're looking at the right exit, then what we're going to say is we're going to say this dot remove the player. Actually, before we do that, we need to go ahead and add this remove player. I think just sets it to null, right? Oh, no, it returns it. So we'll remove the player from this room. So we'll go ahead and grab the player, set the player to null, and then return that player. So we're going to remove the player from this room. So this dot remove player, which is going to result in a player being returned. And we're going to add that player. So let me just cut this real quick. I'll paste it back in here in a second. So we'll say this dot the exits at bucket I dot add. Oh, I need the destination room, the room that we're going to. Okay. Right now, an exit's able to advertise their name, but it doesn't know how to give us the destination room. I need to be able to get the room associated with this exit. So we'll go ahead and generate a getter inside of exit for destination. So we will get the destination associated with this exit. Go back to room. We'll say this dot the exits at bucket I dot get destination, which is a room, dot add the player to that. What player? The player that resulted in removing the current player from this room. Okay? So we're going to get exit I, get that exit's destination, then we're going to add a player to that exit, or to that destination, which is a room. What player? The player that results from removing the current player from this room. Okay, that's what this piece is here. All right, so now we have removed the player from this room, added them to the destination room associated with the exit they chose. So we're finally going to return true. Okay, because we've gone through that room now. If we go through this entire for loop and never find a match, we won't remove them from anything and we'll return false. Make sense? All right, so next class, we're at 11:20, right? So next class we will, we'll have our exam. Class after that, we're going to come in here, now that we have all the pieces, we'll be able to come into player, we'll actually be able to process this and move from one room to another. We're actually only one line away, but whatever. All right, I will see everybody on Thursday for the exam. If you do have any questions leading up to the exam, post them on Slack. I'll answer them, or one of your classmates will answer them. Otherwise, I'll see you then.